All right, so Paul asked me to talk about educational seismology in the U.S., which is really an awfully broad subject. There are lots of different groups. So I'm not going to be able to talk about every group that does educational seismology in the U.S., and it's going to be more of an IRIS-centric view. So, for example, I won't be talking about the Raspberry Shakes, which we already heard about. Richard Allen will be talking tomorrow about My Shake, and then Casper Van Wyck will be talking tomorrow about the TC1 program. So it'll be looking sort of from one particular view. But I thought that it's maybe because we're looking at where can we go in the future, it wouldn't hurt to go back a little bit and talk a little bit about where have we been in the last 20 years for educational seismology. And then I'll talk just about a couple regional examples in the U.S., then more about the IRIS program, some opportunities I see that are possible that I'm hoping will just raise some questions, and then some lessons learned I think we've had over the years working with schools. So, but just before that, for those who don't know the IRIS Education Outreach Program very well, the school seismology is just one part of what we do. We have formal education, professional development, anywhere from grade 6 up through graduate school. We do a lot of informal education, so we have lots of things on the web. We run displays, museum displays, social media. We work with the general public. Then we also have a whole focus on workforce development, so we run an internship program. And we also have a lot of things for early career faculty to try to bring them into the fold. So there's a lot that we're doing trying to bring students from early ages all the way up to becoming professional seismologists. We've even had at least one success who started her career as a seismologist with an AS1 seismograph when she was in grade 8 and is now a practicing seismologist. So that's one person we know went through the entire pathway. So this is what educational seismology looked like in 2003. Just give you an example of some of the different groups. Just a pointer. Yes. So, some of these no longer exist. Some still do. I'll mention Indiana as the longest standing one. And this is when IRIS was just getting started with theirs, and several other groups that are no longer really very active. So it does come to this whole question of sustainability. What does it take to start a network? It's easier, I think in some ways it's easier to start a network than it is to keep it going. So I think it's, if we can, in this meeting, thinking about what does it take to keep a network alive and excited. So I'll give you two early examples from that map. One is I don't know how many people had heard of the Princeton Earth Physics Project, which I think is maybe the first, so maybe the first of the educational seismology programs, started back in 1992. Were there any ones before that, people working on networks, other parts of the world perhaps? But in any case, it was designed using the low-cost GROALPS, which we mentioned this morning. Originally, they had about 80 schools nationally. It was organized as a set of regional networks. So there was a university hub and then schools around that hub. And really, most of those have sort of decayed away now, except for Indiana University still has a very active program. They're still connecting with the students. They're still connecting with the teachers. And I'll show later, they get together essentially every year still for the students. The other one, which I don't think we've mentioned yet this morning, is the Public Sizing Network, which was back, I think my understanding is started back about 1991. And that's the amateur seismologists in California, and that again is still active. I think I know at least some few people here also. Yeah, that's right. You guys were part of it back then, and have been followed ever since. So that's in a sense there's the early citizen science in the U.S. Now then, when IRIS started getting involved around 2000 or so, we had to make a choice of sensor. And we've already heard that there was an animated discussion, I guess, in one of the breakout groups about what kind of sensor to use. So we chose the low end, low sensitivity, open. Students can see how it works. Then of course the other option is the high sensitivity, well networked. At the time when we were choosing, it was actually even networked versus not, because at that point the networking was not very easy for the AS1. I would argue that we had a meeting in fact in 2003, and the two sides fought for 2 whole days about which of these was right, and they got further apart as the meeting went on. But I think now we're at the point that it's clear both are useful. They have different pros and cons. I think it just depends on what your own personal goals are, maybe what your opportunities are, what's the scale of your network, that sort of thing. So if I look at two current networks that are regional networks they're also using the AS1s or something equivalent, and they have two different models in how they run. One is the Boston College Educational Seismology Project. They've got about a little over 20 schools. And what's interesting for them is they actually have a model where the schools pay to be part of the network. So they're in a part of the U.S. and around Boston that has some well-financed schools, let's say. So those schools are willing to pay enough that seismologists or grad students come to their school once a week and actually work in the classroom with the students and the teachers. So it's really your highest end, I think, engagement of the schools, but the schools stay with the program for a number of years because they're getting that direct connection to a seismologist. But you can only do that if you're getting students, the schools are paying a fair amount actually to have that happen. But it means that they have a community that has continued now for, I think they're on the order of 15, at least 10 years, maybe even 15 years. Another example is the Michigan Quakes group. They're not nearly as old. They started really at more like less than 10 years ago. And they have a smaller number of schools, maybe 15 or so, but they're supported by the Michigan State Science Teachers Association, which is an existing community. The community was pretty tight together. They said, let's do this with the seismology, with seismometers. They also had a faculty member, Kaz Fujita, who was very keen. And so they've created a community. They started with a community already, and they've made a community that's even tighter. And so I think that one works because it's teachers helping teachers, and the community had already existed, and so there's a real volunteer ethos there to keep that going. They're also moving towards not just having the schools have their own seismometers, but adding a lot more schools that use JAMA-size, and I'll come to that in a minute, where you can display data, but you don't necessarily have your own sensor. So that brings me to JAMA-size software. We got mentioned, I guess, a little bit this morning. We've chosen like the AS1, to have a very simple software. So it doesn't do very much, but it's designed to be easy for students to use. So it's got very simple filtering, very simple arrival picking in simple locations and magnitudes. We've struggled a little bit in terms of firewalls, and thanks to Paul, I think we've now at least fixed, or at least we've solved a number of the firewall issues. There may still be more left, but it's clearly, when it was first designed, it was designed to go through school firewalls. That was its whole point. And then firewalls got tighter. So the protocols that were allowed through firewalls 7 or 8 years ago are no longer allowed through firewalls, and so we've had to modify. But I think we're making progress, and I think that remains an issue, but I think we're getting better at it. We also, things like it isn't automatically plug and play and update, so we finally have that coming by next week. We should have that running, so in fact you don't have to download a new version. It'll do that for you. But the goal of this was trying to create interactions, because that's what since IRIS overall is all about global seismology networks, groups working together, our goal here is to have schools interact with each other, and also with both nationally and internationally. So this is an example that you can be streaming any data you want that goes to the IRIS Data Management Center. It wouldn't be hard, and we haven't done this yet, to go point to a different web server instead of the IRIS server. And in fact, now we have it set up so we're through the Raspberry Shake folks. You can also, your data from Raspberry Shake can also be pulled into JAMA-size. So like I said, you can be streaming 3 stations at once if you want. That's nice because then students can right away after an earthquake, they can do their own location. But they can be streaming data from any other educational station as well that wants to broadcast their data. Since it's Java-based, it does run on Windows, Mac, Linux. Obviously, where things need to go is to have it all web-based. When we started this, that was hard to do, to have a local sensor and data coming over the web into the same web tool. But now, my understanding is now that's solvable, so that's obviously a direction to go. And the one important thing we'll be adding is the ability to do locations with a single station from the Mars Insight project. So students will be able to download Mars data and do locations with one station. So this is just the example of the simple triangulation. It's just using S minus P times. They move for those who haven't used it, you just get this is interactive, so you can move your trace around on a travel time curve. The circles appear on the map. And so you can have 3 stations, and eventually if you get all 3 stations, you'll find that your circle's close to interact. So yes, this is old style locating earthquakes. It's still what's taught in US schools. So we thought, okay, since this is what the students all get anyway, let's do it, create an interactive way of doing it, so at least it's a bit more interesting than just the paper-based things that they tend to get in their exams. So then in terms of the sort of getting more into our Seismographs in Schools program, we had some years where we didn't have AS1s available. The hardware is now available, and we have some new electronics which is just about ready to come out. There may also be other A&D solutions that are coming along very shortly, like mentioned with the Raspberry, not the Shake, it's the Raspberry Jam. Yeah, so it'll be various options will be out there. For us, a big part is professional development, because we really we've learned really the teachers need regular training. So what we found on a national scale, we just couldn't do enough workshops, because you can only, one workshop you can bring, a good workshop you have 25 teachers, you can also run one for 50 if you want, but you're still not reaching very many teachers. So in this last year, Tammy's led an effort to run an online course that was essentially what we had used to do in person for a three-day workshop, and that's been very effective. So we're expecting to try to expand that to a much larger scale. So now we'll be able to reach teachers all over the country with a standard professional development package on educational seismology. And then the next step from that, that was done in collaboration with the University of Alaska Fairbanks, because right now the transportable array, for those who've heard of it, is sitting up in Alaska. So we had a focus on teaching teachers about this experiment that was happening in their neighborhood. But the goal is then to do the same thing for the AS1 training, because again, we found you can't just, well, in the early days, we just sent people an AS1, just like Engel got one in the mail, sent it to them, not even a manual, just here it is. We've realized that didn't work, so we realized training is necessary. So our goal then is going to be to see if we can even move the physical training we would normally do for the AS1 to an online approach, because then it's much easier to distribute. So in terms of our web pages, again, our goal with the web pages has been to encourage interaction between the schools nationally and internationally, make it easy for schools to view their own data. And we've taken the philosophy, and maybe this is no longer right, and so I'm interested again in discussion, is there better engagement when people have to do something manually? Is it better to be totally plug and play, the data just pops up, or is there some advantage still to selecting your data and saying, oh, there's my earthquake, and I'll upload my earthquake, and then I can share just my earthquake. So that's how our website's been designed. I think there's still value in it, but I don't know of any research that shows whether that's the correct thing to do or not. I'd be very interested to know if anyone else has any sort of data as to what really is the best way to engage. So part of the goal of this was to support the international partners. We worked a lot with Tom, with Paul over the years. And we have, I guess right now, it's about 150 US schools, some 200 international schools are all listed on the website. Something recently, we also, the password, and the account system and the password system had gotten kind of complex. We're revising that. That should be done fairly soon, so that's going to be a much simpler system to use. So then some opportunities that I see. One is we've been hearing a lot about Insight. We'd like to make JAMA-Size the place to go to get Mars data. Since data is going to be sent to the IRIS Data Management Center, we can then use any of the usual tools, pulling it from the Data Management Center, so students will be able to grab it that way. We're also going to set it up so since the Mars data is going to be delayed, the exact amount of delay really is still being negotiated, but we'd like to have it so you could replay it, so you get a sense of it coming in real time, even though it may be delayed 3 months. And we're hoping that really will then, again, engage students with what's happening on Mars, and hopefully then become more engaged with what's happening here on Earth. So part of that with Insight is we're developing a small curriculum working with NASA. We'll have one exercise which is discriminating seismic events on Earth, Moon, and Mars, and talking about what that tells us about the 3 planets. Doing a single event location program. I know others are working on the similar things, so we want to make sure we're collaborating on all the different techniques people are going to use for that. And then another exercise on what can we discover about the actual plate structure from the seismograms. And that one we're still working on. So something new that we have is we now have a new station monitor app, so you can view a seismogram near you. Pick a station near you and you can see it, and it'll also designed so if there is an earthquake on the day, it'll show you up here. Here's your earthquake. You can click on it and then learn more about that earthquake. Now, in the discussions today, I realized that we've designed an app which is for a small group, because this is obviously the group. It's going to be the citizen scientists, the geeks, who are going to care enough to actually want to go look at the seismogram near them. So I'll be interested, again, talk to those people who've tried this to see what's the way to actually make this reach the largest possible audience. But the idea is we can then expand this to, again, because the data will be coming through IRIS, we can use the same tool for looking at Mars data. Because certainly I think for the Mars data, we want to have a viewer and analysis tool that is just web-based, so that we don't, to get the broadest audience, we don't want to be asking people to be downloading any actual software. Then just some potential for citizen science that we've been talking about. One is the Quake Catcher Network. It sounded like there was some discussion at one of the breakouts about that this is maybe an example of a network that was started several years ago, and then use has decayed. IRIS has the opportunity now to get involved to try to resurrect it. Well, I wouldn't say resurrect it, to get it back to where it was and expand it. And now the question becomes, is it worthwhile? And so this is another question that I'd like to have, sort of to the group. Originally, it was designed to do fast locations and to do site response. I think the fast locations now have been overtaken by things like MyShake. And now you've got thousands of stations. You can do fast locations. You don't really need the plug-in accelerometers. You can now get the plug-in accelerometers through Raspberry Shake, though those are 10 times the cost. So the question is a cheap MEMS sensor, they're about $50, is there still a need to essentially get this network going to the point of it actually being citizen science where people can see that data? Or is that, have we now passed, is that sort of, that train gone? And is that no longer a network that's worth, is that no longer one of the citizen science projects that makes sense? So, how many? Okay, good, just about right. So then the second one is something totally different that we started work with Harvard, that they have a digitalization program for taking the thousands of old helicorder records and digitizing them. But it turns out you can't quite digitize it with a computer. You still have some parts of it, of each record, that you have to have a human check it. And so what we're looking at is, can we create a citizen science project so that the citizen scientists will be willing to, for example, check time marks for us and check crossings. If you think of the old helicorder records, big earthquakes crossed, the lines crossed. A computer can't figure that out. So there's been lots of other citizen science projects that have people do what seem like really mundane tasks, but as long as they get challenged and they get feedback and they see that they're helping science, they get involved. So we're looking at this, and again, I'm interested in any ideas people have on what might encourage people to get involved with this, or whether this sounds like just like, wow, you'll never get people to digitize seismograms. So, interested in your comments. So quickly, so lessons learned. I think the continuity has been a big, really, that's been a big plus. Longer programs, you can keep things going. Support through universities is really important. Let students connect with universities and vice versa. I mentioned Indiana that they run an annual research symposium for the students. That's been very popular. Students realize, yes, the work they're doing is can actually be considered research. And then Teachers Helping Teachers works when you have a community of people that are already are together. Challenges, I mentioned the data sharing and firewalls, and then keeping your network running if you're running the high quality equipment, providing the support at a national scale. That's been hard for us. And that's why we try to regions. The lack of continuity of teachers, because the teachers keep changing. So if you're trying to train the teachers, but every 3 years you get a new teacher, that makes it hard in the long term. And then if you're trying to start a network, then finding funding at a regional scale such that you can actually get your network off the ground. Where do you get that money? So, in summary then, I guess I see the two important things is sustained support is needed for it to keep a network going, and collaboration between teachers and between networks is the other, maybe the two most important things to have a network run long term. Thank you.
Thanks very much, John. You can hear me, yeah? You can. Okay, thanks. Very comprehensive. Thank you very much. I'm sure there's quite a few questions arising, so if anybody has a question, please go ahead and raise your hand. Yes.
So I didn't quite, maybe I just went by too quickly. This web-based, I didn't quite understand this new tool that you're talking about to view the data, that it's going to be web-based, which means you can run it on a mobile platform. Could you just, does that exist? Can we play with that?
I can show you, yeah.
What's it called?
It's called Station Monitor. It's on our dev site. We haven't yet released it beyond the dev site, but we're sort of alpha stage, so we can hand out the URL.
And can you just summarize the functionality again?
Basically, it's you come up with if you're on your phone, it says, do you want to see a station near you? And if the answer is yes, it'll show you the web recorder for the nearest station. If there's an earthquake that day, it'll highlight that earthquake, and then if you click on that, then it'll bring up the actual trace of that earthquake. And then what we don't have yet is then the links to, well, then it'll link to other IRIS products for that earthquake. So the idea is then you can learn more about that earthquake, and we're still building some of those learn more about parts.
Go ahead.
Sorry, John, can you demonstrate that at the show and tell tomorrow? Is that possible?
Yeah,
great stuff. Thank you.
Just one question from my side. In relation to the availability of the data from Mars, are we clear as to what the packaging of the data is going to be and getting the schools involved, or are we still in a negotiation process about that?
Let's see, I'm not the most expert. I don't know if Tammy, you would want to say more, or maybe if Jean-Luc could say more.
Hey, Jean-Luc.
Well, actually, if everything is running well, so that's mean landing and deployment of the instrument on Mars, it will be a period. I think something like 5 months without data, or maybe 20 schools around the world will be selected to receive the first data, to see the pedagogic interest with Mars data. After this period, that means we'll be in end of 2019. The data will be provided by all the schools who want to work with this data. But maybe this data will be very boring. I don't know. Just the question is to see the pedagogic interest. Of course, it will be amazing and fascinating data for the student. But after, we have to see if it's interesting to see this. So there is a moratorium with the data. Of course, 5 months after it was decided to deliver data to 20 schools who are very involved in seismology at school, to begin work at school, and then the data will be provided to everybody.
Right. So yeah, once the IRIS is able to have access to the data to give to everyone, we can do that. IRIS also has the capability of, if they're willing to have it go to IRIS early, you can have a password-protected system. So that's our hope would be that they would use that system, and then the schools that were chosen to look at data right away could actually, they could just put their password in and see the data right away.
Sorry, just one question at the back here first. Yeah. Okay, right.
Okay, go ahead. Yeah.
Why is all of the Mars data not immediately available to everybody?
This is a section on its own tomorrow.
So scientists have spent a number of years developing these instruments, promoting this project, getting the funding for this project. They just want an opportunity to do the science and publish the papers. And so it's really about those discoveries. We should be seeing data to the DMC fairly quickly. Summer of 19, the data delivery should start. Once it arrives to the DMC, it arrives in the same format as any earthquake data. So all of the tools that you can access data from the DMC will work on Mars data. So if you've pulled data in any way from Earth, it'll work the same to pull it from Mars.
Okay.
I'm conscious of the time, so I want one last comment.
Justification, I would say. I know it's about you,
right.
But it's completely unacceptable justification. In our community, open data is kind of paramount. And for a project on this scale, funded by so much taxpayer money around the world, I would love to know the name of the seismologists making that claim so we can call them on it when we're at the next meeting.
We'll take that. Braden at the back.
All right.
Oh, we need the.
I think that some scientists would be afraid of high school kids. I mean, it's a compliment for high school children, for education.
Actually, that was one of the original discussions was maybe we let the schools could stream the data, but the other scientists couldn't. And then they started imagining, well, then the scientists would learn about this, and they'd go over to the school, and they'd sit down with the student and look at the data. So this discussion's been going for 3-4 years now.
Final comment to Braden over at the back. Did you want to make a comment?
I had the exact
Same point. Okay, great. So we should press on then. John, thank you very much indeed. And